Hey, welcome back everyone. On this tutorial, we are going to find some probabilities based on a normal distribution. This is a problem similar to the last one from chapter 6, but it can also help you with other probability distributions from chapter 6. So if you're having any issues with that, you may want to stick around and pay attention, and hopefully we can help you with that one. So I have one that is very similar. It's a similar problem to the one that you're facing on chapter 2. Let me just pull it up in here. All right, so it says, given a normal distribution with a mu of 100, so the mean is 100 and the standard deviation is 10, completes parts A through D. So the first one says, what is the probability that X is higher than 90? So we're going to need a couple of things. First, we're going to need a couple of formulas. And the first formula that we need is uh, our C. And this is about comparing our X values into C values. The other one that we need is the X equals the mean plus Z times the standard deviation. As you guys can see, this is the same formula. It's just rearranged. So if you have the X values, you can find C values. And if you have C values, you can find the X values. So it's comparing C values to X values to C values. Both formulas are the same, just rearranged based on what you have. Okay, so what is the probability that X is higher than 90? So before we start, let's take a look at what it's asking us, right? On this one, is saying what is the probability that X equals is higher than 90? Uh, we don't know what 90 is in here. All we know is that the mean is 100 and the standard deviation is 10. So remember, on a normal standard deviation, the mean is always right in the center, right? And the standard deviations, if they're negative, they are to the left. If they're positive, they are to the right. So we know is that the mean equals 100, so it's going to be here. 100 is going to be here, and then this standard deviation is 10. So one standard deviation will be here, and so on and so forth. Well, first thing we need to do is convert this X value into a Z value. So let's go ahead and do that, right? So we're gonna have that Z is going to equals 90 minus 100 divided by 10. So 90 minus 100 equals negative 10 divided by 10 is going to be equals negative 1. Okay, simple enough, right? So we know that 90 is basically what we know is 90 is one standard deviation below the mean. So our mean is right here, our standard deviation is here. So basically what we're trying to do is we are trying to find the values to the right of the standard of -1 standard deviation. So we're trying to find these values here. Okay, so let me see. All right, so we're trying to find these values here. So what we're gonna need to do is we're gonna need to bring our Z table. Okay, here is our C table. You can find that on your textbooks. You can also find it online, but if you look on your textbooks and their appendix, should be under appendix E for the tables. And here is 1. So -1 standard deviation equals 0.587, right? 1.0 equals 0.51587. What this is telling us that of all the values, 0.1587 of the values are going to be to the left of one standard deviation. Okay, so remember, from here to here is 1, and basically from -1 standard deviation to the left is 0.587. But the question is asking us that is higher than 90. So it's asking us for those green values. So what we need to do is we need to give me a second here. So what we need to do is it says 1 minus 0.1587, because we need to find the values to the right of the standard deviation. And once we do that, we get 0. Let me see, 0.8413, and that will be our answer. So once again, all of these values from negative infinity to positive infinity is going to equal to 1. Remember, the probability of something not that something will never happen equals 0. The probability that something will happen for sure equals 1. So the value of everything will equal to 1. But in this case, we need to find the values to the right of -1 standard deviation. So we subtract 1 minus this area here, which we know is 15.87, and that'll give us 0.8413, which is our answer. Okay, B, what is the probability that X is less than 70? All right, let me get my eraser here, delete that. And basically on this one saying what is the probability that X is less than 70? So let me get here. So our C is going to equal 70 minus 100 divided by 10, and that is going to equals -3. Okay, so what we need to do is we go back to, we know that C equals -3, and let's get our highlighter again, and basically we are trying to find values that are to the left of -3. So it's going to be this little tiny part right here. It's so small I can't even draw it with this big highlighter that I have. But yeah, so this value I can tell you right away is going to be very small, right? So let me open the C table again, and here is -3, and the value is 0.014. Okay, so this is simple enough. We don't need to subtract anything because this is less than 70. Because it's less than 70, we just take the value from the C table, which it says 0.014. So the probability that X is less than 70 is 0.0014. Very small value. Okay, that's a very extreme value. Okay, let's go to number C. So this one is a little bit different. It says, what is the probability that X is going to be less than 80 or 120? Okay, so what we're gonna need to do here, we're gonna need to do things a little bit different. Let's start by converting to C values. So C, oops, what did I do here? Okay, here. So let's find C is going to equals 80 minus 100 divided by 10, and that is going to equals -2. So let's pull up our C table again and find the -2, and it's 0.0228 right over here. 0.0228. Okay, so 0.0228. Okay, so basically what we're looking at this, right? So here is here is a -2 standard deviations, or 2 standard deviations below the mean. Okay. Okay, so 2 standard deviations below the mean. So basically what we're trying to find is, we're going to use a yellow marker this time. We're going to find this area right over here, the values over here. And just looking at the table, we know that's 0.0228. Really easy, right? Okay, so that's one. And now we need to find the other one. We need to find out what happened with C equals, 120 minus 100 divided by, not multiplied, but divided by 10, and that is going to equals 2. Okay, so we need to put a C table here, and here is our C value 0.9772. So basically what this is saying, right, when we get two standard deviations, which this one 120 is, so we are the values to the left of 2 is 97.72. So that's what we know here. All of these values here, including that, is 97.72. So what does that mean? Okay, so 97.72. Okay, so but we need to find the value to the right. And so once again, what we're going to have to do is we're going to have to subtract 1 minus 0.9772. And once we do that, we find out that is equal 0.0228. Okay, now we know that the probability that x is less than 80 is 0.0228, or the probability that x is higher than 120 is 0.228. So all we need to do is add those two. So 0.0228 plus 0.0228, that is going to equal, let me where's my calculator here, 0.0456. 0.0456, and that will be your answer. So when they ask you what is the probability that x is on this little area here or on this little area here, let's use this marker here. So basically the probability that x is on this area here because it's less than 80, or on this area here because it's higher than 120 is less than 5%. Okay, let's clear this up. All right, let's move on to the last one. Okay, so it says the last one says 90% of 95% of the values are between what two x values. Okay, so let's think about this for a minute. Okay, so 95% of the values are between what two x values. Okay, so what do we know? We know that from here to here, right, equals 1. All of these values here, everything under this equals 1. That's how much we know. Okay, so well, first thing we need to do then is, because we know we're trying to find 95% of the values, so what we need to do here is subtract 1 minus 0.095. No, minus 95, 0.95, sorry. So that is going to equal 0.05. So 95% of the values are between what two x values. So first we subtract everything under the bell curve is equals to 1. So we need to subtract 0.095, and that'll give us 0.05. Now, what we know about the standard normal distribution is that it's symmetrical, right? So that means out of those 0.05, half of those 0.05 are going to be to the left, and the other half is going to be to the right. So what we're going to have to do is we're going to have to divide the 0.05 by 2. So 0.05 divided by 2, and that equals 0.025. Okay, so what we're going to have to do is we're going to have to go to the C table and find out where those 0.025 is. So let's bring up the C table here and let's find out 0.025. As you guys can see, let's see here, 0.025, 0.023. No, that's not what we want. We want 0.025. Here it is, 0.025, and that is right 1.96. So this is to the left, right? So 0.025, that's the value that we want, and it is to the left. So that's 1.96 standard deviations. So this says that the C value is negative 1.96. Okay, once again, we see here, let's recap. One is all of the values under the normal standard distribution, and because it's asking us to find 95% of the values, so we need to subtract 1 minus the 95% that it's asking us to find. That'll give us 0.025. Because the standard normal distribution is symmetrical, we divide that by 2 so we can find the values to the left, and that'll give us 0.025. We go to the C table, we find 0.25, and it's 1.96. So 0.025 of the values are going to be 1.96 standard deviations to the left. Okay, so it's going to be these values here. Let's just highlight it somewhere, somewhere around here. That's where those values are. Okay. All right. So as we just said, right, this is symmetrical. So to find the other value, right, the other 0.025, because we divided this by 2, we are we know it's also going to be 0.1.96. But to verify that, we pull out the C table again, and let's look in here. 1.96. Here's 1.9. Oops. 1.96. Here's 1.96, and that is give us 0.970. And to double check, here's our calculator. 1 minus 0.0, I'm sorry, 0.9750. That'll give us 0.025, the value that we were looking for. So we are going to use the yellow marker here, and basically is just saying this value here is 0.96. Okay, so we have here 1 minus 0.9750 equals 0.025, which C value is 1.96. Okay. All right, so we know here 1.96 to the left, 1.96 to the right, because we're trying to find 95% of the values. Okay, so now that we have that, we need to do a couple more steps. One is we know that x is going to equals, so we need to use this formula here, right? We have the C values, negative 1.96 and positive 1.96. Now we need to turn those C values into X values. So we need to do the reverse of what we're doing here. Here we had the X values. Now we have the C values. Okay. So what we need to do is we need to use this formula here, and we know the x value is going to equals the mu, which is 100 plus, we're going to open parentheses, and we have negative 1.96, which is our c value, right? Negative 1.96 times the standard deviation, which is 10, okay? And once we do this, what do we got? Let's pull up my calculator here. We have 1.96 times 10 equals 19.6. Is that right? Okay. So we had 100 minus 19.60. That gives us 80.0. Okay. So this will be 80.40. So again, we're just solving for x. We already have our c value, 1.96, and we are using this formula here, and we got 80.6. Now the other x value is going to equals 100 plus parentheses 1.96 times 10, and that will equals all right, 1.96 times 10 equals 19.60 plus 100, and this is equals 119.60. 119.60. Okay, so that will give us the answer, right? 95% of the values are between 80.40 and 119.60. So basically, the values are between here and here. So this will be 80.40. This will be 119.60. So these are our values here. Let's just highlight this. Not a different highlighter here. Let's just pick a different color. What do we do? Let's do light blue. Okay. So these values right over here. This is 95% of your data is going to be here, and that's going to be between 80.40 and 119.60. All right, I really hope that helps. If it doesn't, send me an email, check with me, and let me know what I can do to help you with this. All right, have a good day, everyone.